Alright, 3.2 solving systems of equations algebraically. Bucking up students will be able to solve a system of two variables by using the substitution and elimination method. Solve each system by substitution. So here's how you do it. You get a variable all by itself. Here I already have the variables all by itself. I have y's all by itself. So this one's actually easier. So I'm going to do this one so you can see a little bit harder one, and then I'll let you guys practice on here. So we need something all by itself. Well, x is all by itself with no coefficient, and x here doesn't have any coefficients, but they're not really isolated yet. So we need to get this y on the other side. That's not that hard. Just subtract y from both sides and you get x equals negative y minus 7. Okay, so now that you know something that x equals, you simply plug that x into the other equation for x. So let me show you what I mean. Instead of x on the top, I'm going to write negative y minus 7 minus 2y equals negative 4. So look, I just rewrote this equation, but instead of an x, I plugged in what I knew was equal to x. And there's nothing being multiplied on these parentheses, so I don't multiply anything. I can rewrite this as just negative y minus 7 minus 2y equals negative 4. Combine my like terms, so I have a negative 3y. Negative 7 equals negative 4. I'm going to add 7 to both sides. And so I get negative 3y equals 3. Divide both sides by negative 3. And you get y equals negative 1. Now, I'm going to take this y equals negative 1. And I'm going to plug it back into one of these other equations. I'm going to choose this one because it's already set up to solve for x. Let me show you what I mean. I'm going to write, just go do it over here on the side. I got x equals negative, and instead of a y, I'm going to plug in negative 1 minus 7. Okay, negative 1 and a negative make a positive 1, negative 7, and positive 1 and negative 7 just makes negative 6. So I get x equals negative 6. Alright, well, I'm going to write my answer as a solution set, as a coordinate point. So negative 6, comma, negative 1. Inside parentheses, put a box around it. There's my answer. Okay, see if you could plug y on this equation in for y on that equation and solve for x. And then once you get an answer for x, plug it in for y. I'll have the answer up in just a second. Okay, so I just set these two things equal to each other. Since I have a y equals here and a y equals here, that means that 2x plus 5 equals x plus 3, so that's what I wrote. Subtracted 3 from both sides, subtracted 2x from both sides, and I got 2 equals negative x, which means that x equals negative 2. I plugged that back into the top equation. I could have plugged it into either one. This is the top one, just looked easier. So I got y equals negative 2 plus 3, y equals 1. So that makes my coordinate points negative 2 and 1. And I didn't show you this on the last one, but it's a good idea to check your work. Check it with the other equation besides the last one you just used. And I got y equals 2x plus 5. Plug in all my points. 1 equals 2 times negative 2 plus 5. Negative 4 plus 5 is 1, so 1 equals 1. Yes, that works. So this is really my solution. Alright, let's go on to the next page. Alright, this is the elimination method. I'm going to show you an easy one, and then I'm going to show you how to start practice number 2. So this one's really easy when it comes to elimination. When I mean elimination, I mean we're going to add these equations together so that something cancels out. But let me show you something really quick. What if I just said like 1 plus 2 equals 3 and 5 minus 3 equals 2, and I wanted to just add these equations together? I could do that, watch. 1 plus 5 is 6, 2 and negative 3 is negative 1, 3 and 2 is 5. Look at that, 6 minus 1 equals 5. It's true. It's true, it'll always be true because we're just adding equations together. So, that being said, we could do the same thing with linear equations when we have x's and y's. So let's just add these two equations together. 2x plus x is 3x. Y and negative y is 0, so I don't even need to write it. And 1 and 11 is 12. Divide both sides by 3 and you get x equals 4. Boom! Already got my x. Usually this is the easiest way if they eliminate nicely. If there's fractions, it might not be the easiest. Let's plug it in. So I have, instead of an x, I'm going to have a 4 minus y equals 11. I'm just going to solve. I'm going to add 4 to, or subtract 4 from both sides. Giving me negative y equals 7 and y equals negative 7. Okay, so the last equation I used was this one, x minus y equals 11, so I'm going to test with this one. Let me show you what I mean. Just go right here, and instead of writing 2x plus y equals 1, I'm going to write 2, plug in my x, which is 4, plus my y, which is negative 7, equals 1. 2 times 4 is 8, minus 7 equals 1. Sure enough, 1 equals 1. Checks out. That means that my answer must be 4 comma negative 7. And there we go. I have an answer. So that one was easy because the y's just canceled out right away. But what if we get a situation where things don't cancel out? Right here I'm going to get a 4x and a negative 2y. Nothing cancels out. So here's what I can do. I can multiply this whole equation by 3. Let me show you what I mean. 3 times 3x is 9x. 3 times y is positive 3y. And 3 times 7 is positive 21. Now I'm going to just cross this out, and I'm going to add the top equation and the bottom equation together. And notice now I have a negative 3y and a positive 3y, and they're going to cancel out. So 9x and x is 10x. 3y and negative 3y is 0. I don't even really have to write that. And 21 and 9 is 30. So divide both sides by 10. I can ignore that 0. And I get x equals 3. Alright, now I'm going to take this and plug it back in. I can actually plug it into any one of my 3 equations here, but I would use one of the first ones. And in fact, I'm going to use the top one. So let's plug it in and solve for y. I'm going to say that instead of an x, I'm going to put a 3 minus 3y equals 9. Subtract 3 because I know there's parentheses here, but there's nothing being multiplied by it, so I'm just going to subtract it because it's really being added to negative 3y. So I get negative 3y equals 6. Divide both sides by negative 3. And you get y equals negative 2. Alright, so there's my 2 things, but remember I should check it. And I meant to let you guys finish this one off, so I'm going to have to let you guys try the next one. I'm going to check it, but I'm going to check it with the one that I didn't use. So I'm going to check it with 3x plus y equals 7. And I don't really need to rewrite it, but 3 times my x is 3 plus my y is negative 2 equals 7. 3 times 3 is 9 minus 2 equals 7. And sure enough, it works. 7 equals 7. So my answer is going to be 3 comma negative 2. Alright, why don't you try practice number 3 on your own? And I will say this. It's a little bit harder because we don't have anything that cancels out nice and neat, and everything's positive. So what you multiply is going to have to be a negative. There's a few different ways to do it. Hopefully you find the easiest one, and you multiply by one of these equations by a negative number, and it'll cancel. It'll get one of your variables to cancel out. So I'm going to pause it, let you guys try it, and I'll put the answer up in a second. Okay, I multiplied the bottom one by negative 2. That seemed to be the easiest way to do it. And then I got negative 6x, negative 10y, negative 14. My x is canceled out. Now you could have done this top one by 5 and this one by negative 3, and that would the y's would have canceled out. And that would have worked too. I just think it's more work. Better to just multiply by 1. Solve it out, you get y equals 2. I plugged into the top one. You could have plugged it into either one. I just did the top one. 6x plus 3 times 2. Solve that out, got x equals negative 1. Then I checked it using the other equation, 3x plus 5y equals 7. And it worked out. So that means my answer is negative 1 comma 2. Beautiful. Last thing that you need to know, remember we talked about inconsistent and dependent and independent. Remember that inconsistent meant that it was parallel lines and there was no solution. Well, that's the same thing that's going on when you get like, if you ever solve this and you get a number equals another number, and obviously it's not true, that means it's going to be no solution. And if you ever get something like this, that means that it's a dependent and there's infinite solutions. So just be aware of that. I didn't have any examples like that here, but if you see it, instead of like getting x equals a number, y equals a number, and you get 4 equals 4, that means there's infinite solutions. And if you get like 4 equals 5 or 0 equals 2 or something that's not true, that means that there's no solution. All right, for the summary, I wanted you guys to describe the difference between the 3 different ways of solving systems of equations. You got graphing, substitution, and elimination, and see if you could figure out which ones would be the best to use in different situations. Okay, see you guys in the next video.